Before we attack simplifying radicals, let's spend a little bit of time defining a few things. So please look up at the top here. And I didn't leave room for vocabulary, but I do want to point out something. Number one, this symbol is called the square root, often called square root. But another name for it is simply radical. The whole thing is called radical. So I can read this as radical 50. Or you can say the square root of 50. The number that is inside, and it doesn't even have to be a number, the term that's inside is called the radicand. It can be numbers, letters, parentheses, whatever. Anything essentially can go inside, and we call that the radicand. We don't really say radicand much, though. So the most important part is I will say radical instead of square root. Probably 80% of the time, I'll say radical. All right, so knowing your perfect squares, that's important. And also just knowing basic understanding of what we do with math. So I do want to point out to you that when we are simplifying fractions, most of you probably jump straight to the answer like this and you say, oh, it's 3 over 5. But what was the process that you did? What you did was this. You discovered that when you split the 15 to be a 3 times 5 and the 25 to be a 5 times 5, that the 5 divided by 5 is 1. In other words, this part reduced, or you might say canceled out. Notice this one can be 12 times 2 and 12 times 4. So there's my first step. The 12 is reduced to 1. And 2 times 1, 2 times 2. So again, the 2's drop out, and I end up with 1/2. So that's not the only way to have done it, but that is one process. We just keep finding out all the common factors between the numerator and denominator, which includes A's and B's, etc. So if I write it as this, 6 times 2 times A, 6 times 5 times A. Notice a pair of 6's become 1, a pair of A's drop out, so I'm left with 2A in the numerator and 5 in the denominator. Before we attack simplification, I want to clarify one thing. If I asked you to simplify 24 over 48, and I said simplify, nobody would say 0.5 because that's not simplifying. That is either estimating or evaluating. So estimate or evaluate means give me a decimal version of it, a decimal version, because that gives me the value, kind of like dollars. How much is your watch worth? How much is your cat worth? Give me a value, a dollar value. So give me a decimal value. So if I said, well, evaluate square root of 50 or radical 50, some of you could probably do some of it in your head because it's 7 point something. Or you plug it into your calculator to get about this, 7.1. We are not evaluating. We're not estimating. What we're doing is simplifying in the same way. When we simplified this, we got 1/2, and that's where we stopped. We kept it as a fraction, unless it reduced all the way to a whole number. All right, so that's what we're going to do today as we simplify radicals. Simplifying radicals. Before we jump to there, simplifying fractions mean we need to reduce common factors. That's the key thing. Reduce common factors. And even more importantly, it's the GCF from the numerator and denominator. But that's the idea, reduce common factors. Well, in the same way, when we are simplifying radicals, there are 3 things to consider. These are not steps. Do not think of these 1, 2, 3 as steps. They're just things to consider. Number 1, we have to factor out any perfect squares. Again, not necessarily in order. It's just something that has to happen. Factor out perfect squares. Number 2, we have to remove any fractions from inside the radical. And lastly, we have to remove all radicals from the denominator. So we're going to look at 2 properties. I'm going to focus on the multiplication property first. And it simply says this. Whenever you have essentially positive numbers or 0, what you can do is split the radical. the radical splits up into factors. Notice it does not mean this. It does not mean that I can split when it's adding or subtracting. I cannot do that. What I am doing is that if I have multiplication, I can split the radical. So we're going to look at two methods. One is the formal method that you see in a book, and the other method is sort of for those of us who have a hard time instantly seeing the perfect square, and we need a little bit of help. So here's the official formal method. Notice that the square root of 50 can be written as the square root of 25 and 2. Now, why did I choose 25 and 2 instead of 5 and 10? The reason for it is I need to factor perfect squares. Neither 5 nor 10 are perfect squares, so that wouldn't help me. Now, according to the rule we just looked at, called the multiplication property of squares, or radicals, it can split. And now, we just consider the square root of 25 is 5, and the square root of 2 is the square root of 2. And that's my answer. 5 radical 2. So the key on this one is we factored out any perfect squares. And the perfect squares come out changed, different. So the second method is a factor tree, and this is helpful because it doesn't matter how you break this up. So if you take the 50 and split it up into a 5 and 10, and then I notice that the 10 can split up to a 5 and a 2. The key on the factor tree here is to find pairs. If you find a pair, then the pair comes out. So here is a pair, so that comes out as one of them. And notice 2 does not have a pair to come out with, so 2 stays inside the radical. Kind of like jail, where you have a twin that helps you out, or perfect whatever gets you out of jail, perfect behavior, perfect squares. So the 5s come out, but the 2 is locked in place. So when we do approach the second part, we're going to be using the division property of square roots. And here's a very, very special term. It's called rationalizing the denominator. You're going to hear this quite a bit in lots of different contexts. When we talk about complex numbers, I for imaginary, when we talk about radicals, etc. In other words, when we have a denominator, a fraction, stuff that cannot be underneath, we shouldn't have these. If you have a fraction, you shouldn't have a radical underneath. If you have a fraction, generally we don't have decimals on the bottom, or decimals at all usually. But the idea is, let's get some sort of a whole number down below. A whole number down below. So that's one of the basic things about fractions is the denominator should be a whole number. All right, so notice up here. When I talked about, again, these are not steps. These are things to consider when we're simplifying radicals. We shouldn't have any perfect squares as factors inside any of the radicals. We need to get rid of any fractions inside the radical, and if you have a radical in the denominator, you have to get rid of it. So what we're going to do is try to remove fractions, and what we do is we end up creating another problem for us. So we have to get rid of this, then we have to get rid of this. And how we do that is vaccination, mathematical vaccination. So here's how we simplify something like this. The first thing we do is we use the product property that says I can split the radical. So we split the radical in the numerator and denominator. Of course, this now violates the third part. I'm not supposed to have radicals in the denominator. So what magic trick can I use to get rid of a radical downstairs? This is where vaccination comes in. Just to give you a quick reminder, if I had the square root of 3 and you multiplied it by the square root of 3, anyone know what you get? you get 3. Why? Well, because the square root of 3 times the square root of 3 is the square root of 9. Clean that up. Square root of 9, which is the square root, or excuse me, which is just 3. So, another way to consider it is simply this. If you have the square of a radical, they cancel each other out. The square kills the radical. The radical kills the square. These are the inverses. These are the inverses. So if ever I have the square root of x times the square root of x, I just get x. That's it. Notice I have radical here, I have a radical here, and I can get rid of it. No more radical for you. So how do we vaccinate this right here? You look at the denominator and multiply by itself. Now remember with fractions, whatever I do to the denominator, I need to do the numerator right there. So what happens with the numerator? I get radical 55, and in the denominator, I get 11. And that is my answer. Let's see another one of these real quick. So my first step here is that I can split the radicals like so. And now I need to start vaccinating. So I'm going to multiply by radical 20 in the top and the bottom. In doing so, I get radical 20 in the numerator and 20 in the denominator. Now what do you notice about the radical 20? Well, the radical 20 can be factored, so just over on the side, I'm going to do that. Remember, I can split this up like so. So I get 4 and a 5, a 2 and a 2, so the 2 comes out, and the 5 stays in, and the 20 is still down below. Are we done yet? One more step. The 2 in the front, the coefficient, and the 20 down here can both reduce by 2. So in the end, when you divide these by 2, you get radical 5 over 10. And that is your simplified form. So looking at 11 here, most of us can quickly see that 24 and 10 work. And with the 24, any pair, it doesn't matter at all. Maybe you chose 3 and 8. Over here with 10, I choose 2 and 5. Now here I have a 2 and a 4, and I already noticed that I have a 2 here that can come outside. Now I can keep breaking it up. Notice the 4 comes out as a 2 and a 2. Oh look, there's another pair of 2s. So that comes out as another 2, so I'm multiplying that out. And notice what's locked in place. What stays in? There's a 3 right there that has no pair. And then there's a 5. Notice I'm not looking at the 8 or the 4 because we're just looking at the bottom of everything here. So the 8, the 4, the 24, the 10, we don't consider those. Considering the bottom considers everything above. So I have to take the 3 and the 5 and bring them together. So my final answer is this, 4 radical 15. If you want to see that as the formal route, you would have done this. Radical 16 times radical 15 and 4 radical 15. Because what we've done is 240 is 16 times 15, and the radical 16 becomes positive 4.